pigs that are born at a low birth weight, there's a certain level of I don't know exactly what it is. It could just be, some people have referred to it as fetal imprinting, but basically, even if you refeed them or they regain weight at a faster rate to then be on par with their normal birth weight littermates, or their normal weight littermates, there's still abnormalities that persist, even though their body weight is back to normal.
Okay, welcome everybody to today's Swine Canada podcast. I am Dan Columbus, your host for today's episode, and with me I have Dr. Dylan Olver, who is an assistant professor in vet biomedical sciences at the Western College of Veterinary Medicine here in Saskatoon. So welcome to the show, Dylan.
Thanks for having me.
Yeah, it's a little bit of a different topic today, but we'll get to that in a minute. So before we get going on that, because some of our audience may not be familiar with you and the work that you do, I just ask you to maybe introduce yourself and let us know a little bit about your journey so far.
So, well, in short, I did my doctoral work at the University of Western Ontario. And at that point, most of my work was focused in humans and in rodents. So I'm a physiologist by training, and I study biomedical sciences. So at the core of it, I study the relationship between heart and brain health, with applications to humans and companion animals predominantly, but also to livestock in some instances. From Western, I then went to the University of Missouri, where I completed a fellowship there, and it's there where I got introduced to working with swine. And so they have a biomedical research facility there at their vet school, and it's focused heavily on swine research. They're one of few institutions across the world that has a large focus on using swine as a model of human health. There are several others, but Missouri's a notable one with a long track record of using swine for that purpose. And so it was there that I got trained in working with pigs. And then from there, I ended up at the University of Saskatchewan in their vet school, where I've built a research program that has a preclinical and a clinical side. So the clinical side is operated out of the hospital, the university hospital, and the preclinical side, which is where we use swine, is located here in the vet school. And so that's kind of where I started, and then how I ended up here, and why I study pigs. So I'm not a producer. I have very little knowledge of pigs from the perspective of livestock, but I use them as models to study human disease.
Working with nature and not against it, piglets fed AX3 see significant and improved feed efficiency. Producers know the reality of needing to reduce antibiotic and zinc use. AX3 Digest is a highly digestible novel protein that promotes improved in-barn performance, piglet health, and minimizes the need for zinc in the diet. For more information, visit www.protecta.com. That's www.protecta.com.
Yeah, I'm saying it's a little bit of a different topic and kind of area that we're delving into a little bit, because I think a lot of people aren't aware of the how well animals, and specifically pigs, are used as models for human health and everything. But even like we were talking about before we started recording, that even what we find in the work that we're doing with pigs as models for say humans can apply to multiple species and even pigs themselves when it comes to it. So also will comment too, just because I've been trying to get people to see the benefit of using a pig over rodent models, and I guess we'll get into that when it comes to the cardiovascular work that you've been doing. So I guess that's maybe a good segue into today's topic, is the work that you've been doing in cardiovascular health and pigs, and kind of what you've been finding.
So when I started at the University of Missouri, the group I worked with, which was led by a professor by the name of Harold Laughlin, and so I was working with Harold, and then another scientist there, Dr. Craig Empter, So I was working with them, and they were studying cardiology and heart failure. And the reason they were using pigs was because the pig heart is as close as you can get really to the human heart in a research model. And so they studied heart failure in pigs to try to gain insight onto heart failure in humans. And they were doing everything from examining different drug treatments and the effect on heart failure to putting pigs on treadmills and looking at how cardiac rehabilitation affects remodeling of the heart. And now, just on that note, recently it's been in the news. It happened last year, and now it's happened again this year, that they've actually successfully transplanted a pig heart into a human who had heart failure. So that's just to give you an idea of how similar the hearts are. For over 50 years, we've been using pieces of the pig heart or valves from pig hearts to replace faulty valves in human hearts. And now we're at the point where we can actually take a pig heart and successfully transplant it into a human. Now, a couple of years ago when that first happened, the recipient only survived a couple of weeks, but they think that they've done significant gene editing since then, and hopefully that the heart will be accepted in its new donor now. But all of that to say, so this is what they were studying, was pig heart failure as a model of human heart failure. Now, when I got there, I was really interested in the brain. And so what I did is I started teaching these pigs how to complete different cognitive tasks. And they turned out to be remarkably intelligent by conventional animal standards. So I had previously done work with rodents, and they just kind of circulate and eat their own feces. And so always, when interpreting cognitive behavior of a rat, you always have to take that with a grain of salt. And so when I was at the University of Missouri, they're studying this hard, and then at the end of a terminal experiment, they might just dispose of the carcass. And I thought, there's a perfectly good brain there we could be studying. And unlike rat brains, pig brains, so rat brains are really smooth, and human brains are not smooth. They're what they call gyrencephalic. So they have these deep grooves or fissures in them, and it's a way to pack in more neurons into the same space. And pigs have similar styled brains to humans, which make them a great model not only to study heart failure, but how heart failure affects the brain. And so in this sense, when I got there, I was really excited to start studying the brain of these pigs with heart failure. Because, of course, in humans, it's not entirely ethical to go in and take out a brain from a living human. And so it's much easier to do on a pig that's being euthanized. And so when I started training them in completing these cognitive tasks to see how smart they were, I built this it's called a modified spatial whole board task. And when I had my son complete the task, he might have been 2 or 3 at the time. So I was testing it out on him to see how well he could navigate and solve this little cognitive test I developed. And the pigs that we had exercising actually could solve it using a better search strategy than what my son was using at the time. And so, I don't know what that says about my son's genetics, but or his environment. But what it did tell me is that these pigs are pretty smart, and they were using fairly complex search strategies to solve these cognitive tasks. So they were using spatial and sequential search strategies, meaning that they would go through looking for a specific bait in a specific order so as not to repeat the same mistake twice, which became really interesting. In the paper I published from that, the pigs that exercised actually ended up being so smart that they all completed the cognitive test perfectly, which means there's no error bars on that graph. So there's these heart failure pigs, and they had a more difficult time completing the task, but some of them were okay, but others weren't. And so there's some variability there. But these exercised pigs, they all completed it perfectly, which again, I don't know if that speaks to how smart they are or how smart the person who designed the test was. Because I think they maxed out my sensitivity to design a test. So anyways, while I was there, though, what was interesting is that a producer or someone who studies production became interested and some of the tests I developed. And what they ended up doing was wanting to put in some of my cognitive contraptions into the barns just to provide the pigs with some enrichment, because they noted, they were like, oh, they didn't know pigs were so smart. When I was doing presentations in Missouri and people were saying, oh yeah, these pigs are quite intelligent, then they wanted to modify some of the environments that the pigs were in just to give them a little more engagement. And so then taking the job here, I continued on doing some of that work. So we've been doing, cardiac and brain MRIs in pigs and exercise training pigs and doing cognitive testing. And then after we do those types of tests, we do surgical preparations and look at cardiovascular control and blood flow control in the brain. So we look at how diet or exercise affects cognition and then blood flow to the brain, to see if we can't help offset diseases that affect the brain or develop treatments to combat those.
Yeah, we won't touch on the ethics of having experiments on your kid. I am a little bit interested to know what exercise we need to be doing in order to have a perfect score on this cognitive test.
Yeah, those pigs, a pig can run quite well on a treadmill. Not a lot of people, I'm sure producers know how well a pig can move when it's motivated. But some of those pigs, we were using Yucatan miniature swine for that experiment. And I've put some just commercial land race pigs on treadmills before, but I've also used Osaba swine, we can get into Osaba in a bit here. But there are times some of these pigs have got up over 10 miles per hour on an incline of 10% on a treadmill, which, that's rivaling the most, very, very fit, well-trained humans. So those pigs can move quite well on the treadmill. And once they become adept at it, they seem to enjoy it. They'll do it more voluntarily. Training them to do it takes a little bit of coaxing, but they're smart and they like it. And then, of course, now you've got these little miniature exercise machine pigs that appear to be extremely intelligent. So, the risk is if they become too fit and too smart, maybe they'll take over. So,
yeah, I think we're all very well aware that pigs are able to run. It's stopping that seems to be the problem for them once they get going.
There's been a lot of, I always read in the news the wild boar issues that our province is facing, or Saskatchewan is facing, and how that's spreading across the border and also into Alberta or other parts of the province or Canada. And, there's these farmers and people are becoming concerned with how do you even trap them, because I've seen writing that would suggest you're not to use specific traps because they'll learn how to avoid those traps, and they're extremely difficult to find, and they're fast and strong, and all of these things that I thought, oh yeah, I could see this coming. Pigs are the unknown super species. So
I guess you mentioned that you've been looking at a number of different factors and how this all relates to the cerebrovasculature and cardiac function. So maybe just get into a little bit of that and what are some of the factors you've looked into and some of your findings.
Initially, some of the work I was doing here, we were looking at how diabetes affects cognition and blood flow to the brain. And we were looking at that in juvenile pigs and then sexually mature pigs as a model of kind of adolescent children and then adults. And then we took a separate group of pigs who also had diabetes, and we exercise trained them. Now, the way that we induced diabetes was that apart from giving them like a really high-fat feed, it doesn't pellet very well, but they'll still eat it if there's enough fat and sugar. We also then provide them with sugar water. So as opposed to just giving them regular water, we're mixing bags of 40 kilo bags of sugar, dumping them into rain barrels, and we built a gravity-fed water system, and they're just drinking 30% sugar water all the time. So then over the course of a couple months, these pigs, not unlike a human, start developing the clinical signs of diabetes. And then at some point, they'll pass a threshold where they would be diagnosed with diabetes. And then we start to look at how their blood vessels, how they think, and then how their blood vessels are functioning, and specifically the blood vessels in their brain. And so what we had determined is that we had, again, the young pigs or the adolescent pigs and then the sexually mature pigs. And when it came to the cognitive functioning, it seemed that the diabetes was particularly, harsh on the juvenile pigs. So their cognition really went down. So that would suggest that the high blood sugar and the other signs of diabetes are impairing the neurodevelopment. So the pigs just, they didn't develop properly, and so they never really got nearly as intelligent as all the other pigs. And the exercise, it combated that entirely. In fact, our juvenile pigs that did the exercise training, and that was 3 days a week of interval training on a treadmill, they ended up performing quite well on those cognitive tests. When we moved to the adult pigs or the sexually mature pigs, it was a similar effect, but the magnitude of change was just much smaller. So the pigs that were sedentary and had diabetes, while there were some cognitive deficits, they weren't very robust. And the exercise, though beneficial, wasn't nearly as beneficial as it was in those juveniles. So, that allows me to be lazy, but again, it means I got to make sure my kid's exercising all the time. So, but really, it was quite interesting to see that. And then when we did the MRIs on the pigs and we looked at what's called gray matter, and it's an indirect estimate of how many cells, neuronal cells, there are in the brain. And what we saw is that the exact same trend that we saw in the cognition was mirrored in these brain MRI scans. And what we saw was that the young group that exercised had a lot of gray matter, and the young group that was sedentary and had diabetes, they didn't have very much. And so that effect of exercise was really pronounced in the juvenile pigs. And then in the mature pigs, the effect of exercise was really quite small, what you would call statistically insignificant, meaning that there's perhaps no significance, or what you see as a change might not actually be a change, or beyond what random chance would suggest. And so really these effects of exercise were most pronounced in the juvenile pigs. Now, when we actually looked at the cardiovascular health of these animals, the good news for all of us is that exercise was effective across the board, and the magnitude of effect was similar across the board. So it improved blood flow control in the brain, and it improved how your brain blood vessels dilate to all different types of stimuli. And this is important because reduced blood flow to the brain is believed to be among the number one cause of cognitive dysfunction, so dementia, in early onset dementia as well as adult dementia. So it's a contributing cause is that as you age, you send reduced blood flow to your brain, and slowly then the brain might be starving a little bit. And over time, this accumulates, this effect of starvation might accumulate and cause cognitive impairment or neurological dysfunction. And so these pigs that exercised, they all had much better blood flow to the brain. And when you apply a stimulus to try and relax blood vessels to increase flow to the brain, the pigs that exercised, their blood vessels relaxed a lot and they could increase blood flow to the brain. And then when we took them, after we euthanized the pigs, we harvest the brain and then we isolate individual blood vessels. And so we take out little blood vessels that are about the thickness of a human hair, and we look at how they function. And they all were better in the exercised animals. And it boiled down to, at a functional level, that they had less inflammation. And so there was a protective effect of exercise that appeared to be mediated through a reduced inflammation and an increased antioxidant defense. And that allowed those blood vessels to function properly. And in the sedentary animals, they didn't. And so what that would suggest is that over time, these animals, although in the period of our study, which was only 3 to 4 months long, we didn't see in those adult animals these great cognitive deficits. But over time, the literature suggests in humans, you'll see this. And it could be because their blood vessels are becoming inflamed and have no defense against what's called reactive oxygen species, but for the sake of this conversation, we'll just call it inflammation. So that was some of that work. We have data on their heart function as well, which also improved in the exercised animals, but the part I enjoyed most was the part in the brain. Now, steering from that, this is maybe more relevant to producers, I guess. I feel like I'm on the hook to producers just because I don't know how many scientists are listening who study health. So we started looking at the relationship between body size and blood flow to the brain and pumping capacity of the heart. Because we were dealing with juvenile pigs and mature pigs, we had a weight range from about, let's say, 20 kilos in our juvenile pigs to 120 kilos in our kind of sexually mature pigs. Now, we were using Osaba swine there, so their top end weight is about 120 kilos. And so anyways, we're looking at, apart from just age, how does body size affect some of the cardiovascular parameters that we were studying? And when I started to look into that, a group who I actually had worked with previously, so I once did a visiting scholar fellowship in the Netherlands and worked with a group led by Dirk Dunker and Daphne Merkus, and they had published some papers looking at the relationship between body size and cardiovascular performance in pigs. And I guess the angle that they were taking to approach this question was that the domestication process over the last 100 years has favored, meat quality and different economic outcomes. And so this has resulted in, a disproportional increase in growth rate, fattening, and muscularity of pigs in the last couple 100 years or 100 years. And so when you read some of the early literature, it suggests that, in the early 1900s, it might take 2 years for a pig to get to market weight, and market weight was well under 100 kilos. And now these pigs can reach 100 kilos in 6 months. And so market weight is higher, and they're reaching market weight more quickly, which is obviously that favors, it's because of the selective breeding, favoring economic outcomes, meat quality, fattening, and muscularity. At the same time, it's quite possible that other features weren't selected for, and what they were looking at is kind of the lack of cardiovascular proportionality. So while these pigs are growing much bigger, faster, and that's great from a grocery store perspective, their cardiovascular system isn't developing in tangent or simultaneously at the same rate. And so in that sense, we've also selectively bred out cardiovascular features or function. And so they theorized that this might relate to some of the circulatory issues that modern domesticated pigs face, and also some of the transport-related health issues they face, including mortality. And from there, then we read a study showing that on pigs that show up to abattoirs, when they were comparing hearts that died in hearts from pigs that died in transit compared to pigs that made it through and then were euthanized, and they looked at their hearts, the pigs that died in transit more often had lesions on their hearts, suggesting some cardiac abnormality. And so building on that then, and to understand just the effect of size, you can't take age out of it entirely, but we started looking at how just in regular domesticated swine, differences in cardiovascular and brain blood flow function between 20 kilogram pigs and 120 kilogram pigs. And one of the things that we theorized was that it's possible that because these larger pigs are dying in transit, we were wondering if maybe they'd lost some adrenergic stimulation features. So basically, when there's a fight or flight stimulus, were they not responding sufficiently? And so when their heart gets stressed, maybe it can't pump enough blood to perfuse the whole body, because the whole body is so big in the modern pig. In a small pig, when it's stressed, your heart starts beating faster and beating harder and is pumping more blood. And maybe that's enough blood to meet the metabolic needs of a small pig, But in a larger pig, there might just not be enough blood that heart can pump. So no matter how hard it goes, it can't go hard enough. What's interesting is that, like every other hypothesis I've had, it actually turned out to maybe be the reverse. And so when we started stressing the pigs' hearts under anesthesia, the 120 kilogram pigs, their hearts respond a lot better to pharmacological stressors that emulate the fight or flight response. And that's counter to what A, I would have predicted, but B, what the literature suggests. So normally as you get older, your heart's response to fight or flight stressors decreases. And so they're called beta-adrenergic receptors. And when you get stressed out, activation of these receptors causes your heart rate to go up, and it causes your heart to pump harder. And as you get older, you lose these receptors. And so the same stress doesn't evoke the same increase in heart function. Now, in these pigs, the opposite happened, where the older, bigger pigs, when we induced a stress, they had a greater stress response than the younger pigs, which then that's sending me on a whole different track with this question and wondering, are they hypersensitive to stress? And that's why they're experiencing mortality in transit, is that a stress that a young pig's heart just takes in stride, for some reason, it could be, over the top for these large pigs' hearts. I don't know why they're so sensitive to stress, but they are. So their heart rate jumps higher than a young pig's, and their increases in pumping capacity go higher than a smaller pig's. And so something's going on there where they're defying kind of conventional, at least human physiology, and we're still trying to tackle that. But they did show heightened sensitivity to stress, which is just the opposite of what you might expect.
Interesting. I always think it's more interesting when you get something that you don't expect, and to just prove your stuff. Although the students that are writing this up might not agree when they have to go and try to explain that. I guess this is a good segue, and I think maybe this will also make the producers listening a little bit happier, and a shameless plug for our collaborative research, because we did work with low birth weight, which is also an increasing issue when we're selecting for increased litter size, and then what that means when you put that in for nutrition. So I'm just wondering if you want to comment on that study and what you found with that.
So in that study, we were looking at how, so obviously the original study was yours, and you had this complex design of investigating how birth weight and refeeding affect growth performance in swine. And from that, I basically was able to build a sub-study just looking at how birth weight alone affects cardiac function as well as cerebrovascular function. And what we saw there was that there are certain parameters. So pigs that are born at a low birth weight, there's a certain level of kind of, I don't know exactly what it is. It could just be, some people have referred to it as fetal imprinting, but basically, even if you refeed them or they regain weight at a faster rate to then be on par with their normal birth weight littermates, or their normal weight littermates, there's still abnormalities that persist, even though their body weight is back to normal. And so we saw altered pump mechanics in the heart of pigs that were born with low birth weight. And this is, 26 and 56 days after birth. And in some cases, by 56 days, their weights were close to the same, and they'd undergone this kind of catch-up growth. And we saw dysfunction in the blood vessels in their brain. And specifically what we saw was an impaired capacity of blood vessels to dilate, owing to reduced nitric oxide. So nitric oxide is this molecule that causes blood vessels to relax, and impairments in nitric oxide signaling, they underlie a lot of things. So erectile dysfunction, pulmonary hypertension, heart attacks. There's all sorts of things that if you have impaired function of this molecule from a human health perspective, it's detrimental to blood flow and then organ function. And in these low birth weight pigs, even at 56 days of age, and many of them by that point had undergone catch-up growth, they still had impaired nitric oxide function in the blood vessels in their brain. And what's interesting is that if you look in the human literature, kids that are born with low birth weight, even if they lead otherwise healthy lives, they're at a greater risk for dementia later in life. And one of the potential mechanisms is that the blood vessels in their brains might not be dilating as well owing to this impairment in nitric oxide. From a producer perspective, though, you have to wonder if these cardiovascular impairments persist even after the pigs have undergone some catch-up growth. Is it perhaps these pigs that when they get to market weight and are shipped off, the ones that are showing up and they die in transit and they have these cardiac lesions, is this something that perhaps these were low birth weight pigs and they have these underlying cardiovascular issues that they just didn't develop properly in utero, and then nobody is really aware of that, and then when they get shipped off, they're dying. And so that's not confirmed. It's just something that I speculate, because we do see alterations in the way the heart works and the blood vessels in the brain work. And of course, if blood flow to your heart or your brain cease for even a little, like a brief second, that can have catastrophic effects on life. So
yeah, it's definitely something I think we should look into. Just, when it comes to low birth weight pigs, and I think producers are very well aware of these, and nutritionists as well, the focus is on, well, how do we get them to grow like their normal birth weight? How do we get them to market at the same time, right? And less so about, well, what are the other potential negative impacts that low birth weight is having on them? And it would be horrible to go through all that time, bring them up to market weight, and then they die on the truck because of a cardiovascular problem that started because they're small, right?
Something else from that study made me think about was that, so one of the features of my research program that I study, and this has been an interest of mine since I started in grad school, is the first paper I published, and I'm still doing studies on this today, which is looking at how insulin dilates blood vessels. And so in the 90s, it's been studied for about 80 years now. But in the 90s, researcher Elaine Barron did this study, and he showed that, so when you ingest sugar, you secrete insulin. Insulin causes that sugar to get taken up into the muscle. But it also causes the blood vessels in your muscles to dilate through that nitric oxide molecule. And that dilation then facilitates more blood flow to that muscle, which delivers more nutrients to the muscle and more insulin, and further increases the glucose uptake into the muscle. And it's estimated that dilatory effect of insulin accounts for about 30% of glucose uptake into the muscle. So you're delivering more sugar to the muscle. Now, if you have impairments in nitric oxide, insulin-induced dilation, it doesn't work. And so insulin then doesn't dilate, and instead it causes constriction. And it got me thinking with those low birth weight animals, when we were, you were talking about the refeeding and the catch-up growth. And from the human literature, a lot of times that catch-up growth is associated with insulin resistance. And so vascular insulin resistance is characterized by impairments in that nitric oxide signaling. And if those low birth weight pigs, if they have impaired nitric oxide signaling, it's quite possible they have vascular insulin resistance, which means that when they're trying to take sugar up into their muscle, impairments could be as large as 30%. So they're less efficient at storing nutrients in their muscle, which would delay their catch-up growth, possibly related to this nitric oxide molecule. And so, becoming insulin sensitive from a vascular perspective might actually increase muscularity in these animals, as they'd be able to take up more nutrition into their muscle.
I mean, that was part of what we were trying to do with that study, and find out why these pigs don't respond the same way. I don't know if there's anything we can measure in what we took from that, but that would definitely be one of the interesting outcomes for that, because it is a question, right? Why do these low birth weight pigs never seem to grow as well as their normal birth weight counterparts? Even though you throw more nutrition at them or whatnot. So
yeah, and so from the cardiovascular scientist in me, I'm going, that could just be insulin resistance, obviously at the site of the muscle, but also in the cardiovascular system.
No, I think it's good. I mean, also then just for the purpose of today's podcast, talking about the models, right? How even something like this can then potentially give us ideas of what to look for specifically in the animal sciences to look at a problem that we're having. So obviously benefits of the collaboration.
And vice versa, right? You hear about these abnormalities or these questions. And so now this birth weight and refeeding question, to me, it's launched my mind on this insulin signaling. And so when I have time, that's something, I want to pursue from a granting perspective to see, because it's I have a fairly strong background in insulin signaling in vascular tissue as it relates to muscle metabolism. And so I've always thought, okay, well, when I get back, the data now are published. So getting back to that, that's one of the next big studies I want to do, is write a grant for, is to get that going, so that to see, is this what's going on? Because it serves producers, but also then from the human perspective, these are problems that children are facing as they develop, and kids are born low birth weight all the time, and this wasn't complicated low birth weight. This was just uncomplicated low birth weight, so just small for gestational age, which is a true value of that work. So it's a very high prevalence problem, if that makes sense.
So before we get to the end, is there anything that you want to talk about that we haven't?
No, I will plug the Osaba swine, though. I guess that would be it. So the Osaba swine, I've done some work with them, and I might actually be going down to the States to do some more work with them. But a researcher about 30 years ago went to Osaba Island off the coast of Georgia, trapped these pigs from that island. Apparently, they were brought over from the Spanish when they came to America. And then they left them there. And then this island goes through these periods of, high food availability and then low food availability. And the only pigs that ended up surviving were these ones that had a propensity to gain fat, because then when it was no food availability, they could withstand a year or two on their existing resources. And so when this researcher went and trapped and then he colonized them for a research study as a model of kind of modern day diabetes, of just diet-induced diabetes, because they develop all the clinical signs of obesity, including obesity, quite rapidly. And that was their survival mechanism when there's no food around. But in an environment where there's perpetually lots of food around, it's not a great survival technique. And so anyways, we've done some work with those swine, and now we're hopefully getting into more. But the reason I'm bringing it up is I recently interacted with a farm out of Alberta, and they were using these Osaba swine. I guess they're like delicacies. So their meat is used for prosciutto, and they've got all sorts of it's like the Wagyu beef of the pork industry. Maybe not that. I don't know what I'm talking about. But, just it's this really delicate swine, which, again, I had no idea. I've been thinking about them as, this model of diet-induced obesity and diabetes for so long. And then I found out that, it's actually the finer cuts of pork that these pigs are known for, at least on the producer side. And so it was something I thought, oh, this is super interesting. But that's who I ended up getting some Osaba swine for some of my research. And anyways, it was entertaining, to say the least.
It sounds very similar to the Iberian pigs, which again are the same type of, the fat deposition and everything with them is very different. And I've actually been involved in some other model work where we were looking at and I'm probably going to butcher it, but non-alcoholic steatohepatitis. It's like basically liver problems and high fat diet. So it's one of those things. Okay, you're looking at them. You might have benefits with the cardiovascular, cerebrovascular, but you might be ruining their liver. So just watch out for that. So I guess before we get to everybody's favorite 3 questions, I will just ask, if there's 1 or 2 take-home messages that you want the listeners to get from today's episode, what would those be?
One would be I'll take this chance to advocate for physical activity. So get out and exercise, be active, and try and be active every day. And that will be beneficial for your health span and life. So that's one thing. And the next thing is, I guess, I didn't really, I'll say thank you to the swine industry just on account of there's just so many different doors that get open there and so many overlaps of ideas and potential synergies and all these things there that I just was never aware of. And then I got involved in it. And whether it's, enrichment in a barn or low birth weight and nitric oxide signaling or the effect of body size on cardiac function, there's just been all these overlaps and everything just keeps building and building and building. And so I'll just thank the swine industry they're very open and everything's been great. So
always one of the benefits that I see of working in pigs is that we benefit more than just our industry. I would be interested to know if we see an uptick in gym membership applications after this episode with the ones who hopefully we get some people out there and on the treadmills and benefit from that.
It's time for our famous 3.
Okay, so before I let you go, we have our 3 questions that we ask all of our guests. The first one, I'll tweak it a little bit because we normally ask about a swine resource, but that might not be as applicable. So maybe just your favorite science-related or something in your field resource that you kind of always go to.
Well, a book in the swine world that I like is it's by Michael Swindle, and it's called Swine and Biomedical Research, and it's basically the resource of all people like me who use swine as biomedical research models, because he breaks it down really well and goes over all the details required to study swine. And I mean, in my world, swine are a whole different beast. A lot of people are used to working with mice and rats, and they just have no concept of what it means to work with large animals and work with them on a throughput that's required for science, which is nothing like production animal throughput, but just even the physical limitations to working with them. And this book covers it all. So it's a great resource for scientists who do swine work or for those that don't but want to know a little bit more about it. So Swine and Biomedical Research by Michael Swindle.
I haven't heard of that one. I'm going to have to look it up too, because I delve into that every once in a while, and then I'm always asked, why are you working with swine and not rodents? So that might be a good one to look up.
The FDA now, I know that the FDA for a number of their approvals now require that you go through a large animal model first. And so only to say that the value of swine and biomedical research is only increasingly being recognized. So one of the issues we face in my world is that a lot of times things, almost any intervention you see that's applied to a mouse or a rat seemingly works. And so in my PhD, as I was saying, I did a lot of rodent work. We were studying diabetic neuropathy. And it seemed that in the literature, no matter what you did for diabetic neuropathy, the issue was solved in the rat. And the treatment restored blood flow to the nerve and nerve function. And then when you look at the number of successful treatments in humans, it's basically non-existent. And so from that, it's just, well, how well do these lower order species reflect the human? And the short answer is maybe not as well as we had hoped. And so this is where I think there's going to be an increasingly large role for swine and biomedical research, because the FDA has picked up on this and they're saying, in order to take your drug to the next level and eventually see that if it's effective in humans, you need to show some evidence in a species that is not a rodent. And so that's where it starts. And I think then from that is the trickle down effect where independent researchers are going to start going, they'll see the value in swine.
Well, hopefully that means our grant applications in the future are a little bit easier to get past the reviewers. So, so our next question is a book or resource that you kind of go to or you particularly enjoyed outside of science in your field.
Okay, so I'm when I moved to the States, I became really interested in the American War of Independence. I became interested in the War of 1812, the Civil War. And one of the books that I read that I absolutely loved was by Ron Chernow, and it's a book called Grant. And it's a biography of Ulysses S. Grant, who led the Union Army, and it's a fantastic book. Ron Chernow also has a book on George Washington, which is equally as fascinating, but I guess I favor his book on Grant. So that'll be my recommendation. It's not small, but it's so thick it'll make you look smart just holding it.
Well, there you go. Maybe that'll be what gets people out there to get it. And then our final question is, when you look back at particularly successful or effective leaders, what is an attribute or characteristic that they have that you think makes them particularly successful?
All of the, I've had great mentorship. Every advisor I've had and every supervisor or mentor I've had, I literally, all the degrees I did, I just followed strong mentorship. So I didn't go to I literally just, after meeting with these people, decided this is who I want to work with, and that's what guided everything else. And across the board, I would say all of them were adopted a player-coach style. And so I found that to be very successful. I don't know if it's successful for everybody, but the mentors I had all seemed to be player coaches. So they were willing to get in the trenches. Washing a lab dish wasn't beneath them, and they led by example and at all times. And so, not only in the lab, but outside of the lab, I often strive to be a little more like my mentors. So I admired them not only professionally, but personally as well. And so at the end of the day, I think a commonality among all of them is that they were player coaches and just led by example. So,
yeah, I always find that's an interesting question to ask and hear what people say, because, it's also going to come down to what you would need as working under them, right? Sometimes I feel like being that player coach, that me going in and trying to help my students at this point is more of a hindrance, but maybe in some situations.
My one mentor, his name Harold Laughlin, who I mentioned earlier, there's a line in the lab with duct tape on the ground where he wasn't allowed to come past that line if we were running experiments, because as soon as he showed up, all the experiments start failing if he crossed that line and wanted to look at what was going on. And so he just put this duct tape line. That's where you stop. You can have your coffee and throw comments at us, but you can't come any closer than that.
I'll have to tell my students to do that. Put tape where you don't want me to go.
Yeah, exactly. And so anyways, I have a million stories about watching him come into the lab and turn things around for us, watching his mentorship, or students who I was trying to get something out of, and I was just failing to bring out their best. And somehow he was able to elicit peak performances on a consistent basis from everybody. And so I don't know how he did it all the time, but watch the number of times I watched him just empower people to do better. Like if I could bottle that and then feed it to my students, not that I'm upset with my students, but just I would, and I don't have it, but he does. And, I was lucky enough to work with someone who had it. So you get to see it, and then you get to reflect on how you don't have it for the next 30 years.
I was going to say, if you have any tips or tricks, I'd love to know, because that's something that we always want to know. But yeah, so, okay, well, I guess that brings us to the end. I think we've gone enough time for our people, our listeners. So I will thank you again for coming on and joining us. I think I really enjoyed the topic. I hope other people do as well. I think it was very interesting to see a different side of pig research and what we can do with swine. So I'll just, like I said, thank you again for coming on.
Thanks for having me.